Welcome back. In this video, we are going to solve problem 9-43 that is taken from chapter number 9, Stress Transformation, and book name is Mechanics of Material by Rc Hibbeler. So statement is the nose wheel of the plane is subjected to a design load of 12 kilonewton. Determine the principal stress acting on aluminum wheel support at point A. So you can see this is the plane wheel that is subjected to 12 kilonewton load acting on nose wheel at this point, and this is the wheel support. So you have to find the principal stresses at wheel support at point A. And from here you can see this is the cross section of this portion at this portion. So 20 millimeter plus 20 millimeter, so total height is 40 millimeter and width that is in this direction is 30 millimeter, and this is point at mid we have point A. So let's start with the solution. So first step is that if you cut this wheel at point at this portion and draw the free body diagram. So I will first draw the free body diagram. Let this is the wheel there, and this is the shaft of the wheel. Let me extend it. Okay, and then you have the wheel support that is like this. Clear? Okay, and then you have, so when you cut it at point A, you will be having a normal force that will act on this surface. Let this normal force is represented as N, and you will be having a shear force that will act over this surface. This will be the shear force in this surface. Clear? And you will be having a movement as well. This movement is M. And you can see this, there is a load of 12 kilonewton that is acting on nose of the wheel. Clear? And distance between this nose of the wheel and this point A is 150 millimeter. So this distance is this distance, and this point A distance, this distance is 150 millimeter. So we will find these reaction forces and moment by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along y direction must be equal to 0, and here we will take the y direction in this direction is taken as positive. Because why we are taking this, so you can see this is the new transformed portion. So we are taking all the forces in this direction as y direction, and this direction as taken as x direction. Okay, so now you can see that this force N which is acting in the opposite to that, so it will be minus N, and you can see from here that this is point, so this is point A, and if you draw a horizontal a line, so this angle is 60 degree, so remaining will be 30 degree. And you can see that if I draw a line parallel to this line which is 30 degree, making 30 degree with this vertical line, so it will be like this. Clear? So we will resolve this 12 kilonewton into two components. So one component will be in this direction, in x direction, and other one will be this, and this angle will be 30 degree. Why? Because you can see that this is the vertical line, so this is a vertical, this is the line, this is, so that this angle will be also 30 degree. So this component will be 12 into cos of 30 degree, and this component will be 12 into sine of 30 degree. Now sum of all forces along y direction must be equal to 0, and force in this direction is taken as positive. So N, and this component is in positive y direction, which is 12 cos of 30. So I will write plus 12 into cos of 30 degree is equal to 0. So from here you will get N will be equal to 10.392 kilonewton. Similarly, you can find this shear force. So for that we will apply equation of equilibrium, that sum of all forces in x direction is taken as uh, is 0, and force in this direction is taken as positive. So you can see this shear force in this direction is positive, and the other component, this is in negative direction. So I will write V minus 12 into sine of 30 degree is equal to 0. So it means that shear force comes out to be 6 kilonewton. Now we will find this moment. So we will find this moment by using equation of equilibrium, that sum of all moments about point A is equal to 0, taking the counterclockwise moment as positive. So you can see this moment about point A is counterclockwise, so it will be positive, and the other moment about this point A is, this is the perpendicular distance, which is 150 millimeter, and this is the force, and this is producing clockwise. So their sum must be equal to 0. So m minus 12 into 150 millimeter, which is in meter is 0.105, is equal to 0. So from here you will get moment will be equal to 1.80 kilonewton into meter. Now you have this normal force, you have shear force, and you have moment as well. So you can see that due to this normal force, we will have a normal stress. Due to this force, shear force, we have shear stress. And due to this moment, we will be having a bending moment. So this is the combined loading. So for normal stress, I will write it normal stress. So normal stress will be equal to sigma, and that is equal to N over A, which is the normal force, plus minus M into C divide by I, or you can also write m into y divided by I. Okay, as this normal force is toward this surface, so it will be in compression. So we will take this stress as compressive stress. So in compressive stress we can write it as minus. Okay, so N is 10.392 divided by area. So cross section is given as 20 by 30. 20 is height and 30 is width. So 20 millimeter in meter is 0.02 and 30 is 0.03 meter. Clear? And you can see from this cross section, this is point A, so this will be the neutral axis. So at this point A, we have this C is distance from neutral axis till topmost, or we can also correct it and we can write it as y, m into y divided by I, and y is distance from neutral axis till any point. So this is y. So here y is equal to 0. So it means that stress due to bending moment will be 0, and we will only have this compressive stress. So sigma will be equal to 8.66 megapascal. Also you can see n is kilonewton, so I will multiply with 3, and this will be minus, or you can say 8.66 megapascal, and that is in compression. Negative sign means it is in compression. Now we'll find the shear stress. So we know that shear stress at point A is equal to V into QA divided by I into T. And what about QA? So QA will be equal to Y dash bar into A. So this is the point A. So above point A, this will be the area, and this area is 30 millimeter into this 20 millimeter. One more thing is that this total is 40 millimeter. So this is 20 each, so 40 millimeter. So I will also correct it over here that this is 0.04. Okay. So y dash into A. So y dash is distance from neutral axis till mid of this section. So till mid of this section, this distance will be equal to 10 millimeter. So this will be 10 millimeter, and that is equal to 0.01 meter. This will be y dash bar, and this area will be equal to 30 multiplied by 20. So I will write it. Y dash is 0.01 and area is 30 millimeter, which is 0.03, and width is 0.02 meter. Clear? And we have V value, which is this one, 6 kilonewton. So you can just put it 6 into 10 raised to power 3 multiplied by QA, which is 0.01 multiplied by 0.03 multiplied by 0.02 divided by thickness. So thickness, you can see this is the thickness. So this thickness is 30 millimeter. So I will write 30 millimeter in meter. It is 0.03. And what about I? So I for this cross section about this neutral axis. So this is its width and this is its height. So width is 30 and height is 40. So for cross sectional area of rectangular, we can find it 1 over 12 B. B is 0.03 and H is height is 0.04 whole cube. Clear? So you can find the shear stress. So when you calculate it, will be 7.50 megapascal. So if you draw the state of stress on the element, so let this is the element. Clear? So you can see sigma y, which is this one in this direction. This was y, so this is sigma y, and that is 8.66 in compression megapascal. In this direction we have taken x, so sigma x is not available. Sigma x is equal to 0, so there is no need to represent it. And tau of xy is this one, which is the tau a, which is tau of xy is equal to 7.50 megapascal. So we want to find the principal stress. So we know that principal stress sigma 1 comma 2 is equal to sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. So put the value 0 minus 8.66 divided by 2 plus minus 0 minus plus 8.66 divided by 2 whole square plus tau of xy, which is 7.50 square. That will give you sigma 1 comma 2. So when you add it, sigma 1 will be equal to minus 8.66 divided by 2 plus under the root 8.66 divided by 2 whole square plus 7.50 whole square, and that will be equal to minus 4.33 plus 8.66025. So when you add them, you will get sigma 1 comes out to be 4.33 megapascal. Similarly, you can calculate sigma 2, and sigma 2 will be equal to minus 8.66 divided by 2 minus under the root 8.66 divided by 2 whole square plus 7.50 whole square, and that will be minus 4.33 minus 8.66025, and from here you will get this as minus 13 megapascal. So your principal stress sigma 1 is 4.33 megapascal and sigma 2, which is minus 13 megapascal. So these are the principal stresses that is acting at point A of the wheel support. And that was all about this problem 9-43. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.